Alright, welcome to the next video. This one's going to be about graphing functions and how to identify whether a graph represents a function or just a relationship by using something called the vertical line test. So we'll get to the vertical line test to kind of discover it by looking at a couple of graphs that I need to make. Okay, so remember that a function has an input and an output. Actually, any relationship should probably have an input and an output. And we're going to graph the input, which is the independent variable, on the x-axis. So you want to get these words associated in your mind. Independent variable, x-axis, and input are the three things that correlate together. And then your output is on your y-axis, and that's your dependent variable. Okay, so the reason it's called a dependent variable is because the output value depends on what you input, or what your independent variable is. So let's just make a couple of quick sketches on these three graphs, and then try to identify whether or not they're a function based on that definition of a function. So let's make the first one be a circle. Let's make the next one be a wavy line like that. And let's make this one be a sideways looking curve like that. Okay, so to identify whether or not each graph is a function, we have to remember what is the important characteristic of a function. Okay, so what makes it a function? So remember, a function has input and output, true, but the real criteria is that for each input, there can be only exactly one output. Okay, so your input is the x-axis, so pick some x value, like, for example, right here. This corresponds to x equals 0. Now, if I input x equals 0, what's my output value? So my output value is where my function is graphed. So if I'm sitting here, I look for the output value and I see it right here, but I also see it right here. So I can see that if I input x equals 0, I have two possibilities. The first possibility is around 4, and the second possibility is 1, 2, 3, 4, like negative 4.5 or something like that. So if I input a 0, I have two different outputs, and that's not a function because a function has exactly one output for each input. Okay, so this one is not a function. How about this one? Let's pick an input. If I input 0, I get out negative 1/2. What if I input a 3? I get out negative 2. What if I input 4.5? I get out 0. So my input is my x value. My output is the y value here, here, and here. And you can see that no matter what value you pick as your input along the x-axis, there's only one possible output. There's no points on this graph. There's no place on the x-axis that you can say, at this particular x value, I have more than one output. No, there's always one output, so this is a function. Yes. Okay, how about over here? If I pick this point as my input, how many outputs do I have? I have 0 outputs. So what that means, if you recall, is that is not part of the domain. And that kind of makes sense because the graph doesn't actually go over here, so it's not part of the output. It's not part of the domain. There is no output. So this input value of 1, 2, 3, 4, 5, negative 5 is not part of the domain. Okay. How about right here at negative 3? There's exactly one output. Okay, great. It seems like it might be a function. But then I come over here to negative 2, and I can see I have one output right here and another output right here. So I have two possible outputs, which means it's not a function. Okay, so you can probably see why it's called the vertical line test. Let me just zoom ahead to the slide here. The vertical line test says if you draw a vertical line, it must cross the graph exactly one time. So any vertical line must cross the graph exactly one time. And that's because the number of times that it crosses is telling you how many outputs there are. And the definition of the function, remember, was that for each input, that's a single vertical line, there can be only one output, which is a number of times it crosses the graph. If it crosses more than once, it's not a function. And if it doesn't cross at all, then you're not in the domain, right? So remember, the domain is all possible inputs. So if you're not crossing the graph at all, you're not looking at any possible input values. As you can see on this graph, any of these vertical lines that don't cross at all are out of the domain. And then here we're crossing once here, once here, once here, once here. And you can see it's not a function because there's two outputs for a single input. Kind of like if this was supposed to represent age and height. At a certain age, you can't be two different heights, as we saw before. Okay, that's it for this kind of visual representation. And then in the next couple of videos, we'll look more closely at the details and then finally the notation and mathematics behind it.